Hi guys, welcome to Learning Electronics Repair. This is my fake MOSFET tester that I lashed together, as you can see. Just like that, yeah, no circuit board, no Vero board or anything. And this actually works. This detects fake MOSFETs. There's almost 20,000 views on the video where I explained how to build this. And I've also used it 3 times now to determine if I have real or fake MOSFETs in my repair work. Twice it said were fake, and they didn't work in the circuit, and once it said they were genuine, and that one did work. So this has got a good track record. What I'm going to do today, thanks to PCBway.com, is make a deluxe version of this. So let's have a look at what features I've added. Let's discuss various options with this, and then we will upload the PCB Gerber files to PCBway.com. We'll get them ordered at revision 0, and I'll explain a few tests I want to make. Here are my development notes, Dickie card, yeah. So you can see this is where I was actually working on the device. Yeah, lots of notes and things all over it. But I've actually created a schematic now, so this was effectively the working all this out of my head stuff, yeah. The actual schematic is here. So the features I've added to the project. First of all, I've added 4mm banana sockets, as these things are called, to attach your bench power supply, your multimeter. And we have another connector here, gate drive. We'll talk about that in a minute or 3. We have the addition of testing N-type or N-channel and P-channel MOSFETs, so we can test both types. I've added the facility to test with the gate voltage of 10 volts, 5 volts and 3.3 volts. Now, the reason for this, all the data sheets I've seen, but I haven't seen all data sheets of course, test the MOSFET RDS on with a 10 volt gate drive. But you may be interested to use this for other purposes. For example, if you're building projects yourself, you want to use a particular MOSFET controlled by a microcontroller, and you're going to drive it at 3.3 volts or 5 volts, you may want to know what the RDS on is. So I've made it switchable between the 3. I've also added a 10 amp test range, drain source current 10 amp, because a lot of data sheets specify 10 amps as the test current, sometimes more than that, 20-30 amps, but it's an option to test the MOSFET at higher current. The gate drive connector I mentioned, this option allows you to, for example, drive the MOSFET with a square wave or something similar. This may be useful if you want to measure the gate capacitance, or another important factor is the turn on and turn off time of the MOSFET. You're probably going to do that with an oscilloscope, to be honest. So I've put the option on here, you can drive it in that way, but so far I haven't actually tried doing that, okay? The last thing I added was the option to test various SMD MOSFETs, and that's what we have here. Some adapters for the common packages. I probably don't have all of them, probably missed 1 or 2 of the common ones, but these are the ones which I found so far. I came up with rather an innovative way to actually make these. I think you'll like it. You'll see when we look at the PCB layout. But back to the schematic. Now you'll see I have here a 4-pole, 4-throw rotary switch. This is not a very standard thing. You can get them easily enough on AliExpress. So I'm using this type of switch. You see they come in various options, but 4-pole, 4-throw. This is not a very standard component. You would have to buy one of these most likely. Probably not something you have lying around. But you only need this switch if you want to implement all the features of the tester. You'll see what the switch does here. So AW, CW, BW, DW. These are the wipers for the 4 poles, okay? And the 4 positions. Now, I'm switching the Zener diodes you see here and here. The reason we have 2 lots, this is for the P-type and N-type testing. Okay, we need them in different polarities, so we have these. And you look here, so these are the 2 resistors which feed the gate voltage in here, and they also connect to the switchable Zener diodes. Okay, and they switch on these switches. So this is A pole and C pole, and you'll see in the 3 positions where we select a Zener, we also connect to the gate. So we're connecting the gate to that Zener, yeah, via the other switch. In the 4th position, the gate is not connected, it's disconnected, okay, and this is not connected to anything either. And we now have these 2 connections here, these 2 nets, external N gate, external P gate. So you've now disconnected everything from the gate, and you can drive it as you wish externally. As I mentioned, you probably want to do that if we want to try to measure switch on and switch off time for the MOSFETs. If you don't want that feature, then in fact you don't need this at all. We just need a 2-pole 3-way switch to switch the Zener diodes, and this then connects directly to the junction of the 2 resistors and also directly to the gate. So if you want to exclude this feature, you don't need it. You can use a much simpler switch, okay? We see 2 LEDs. This again is because of the N-type and P-type. Now, there's no switch on this to switch between the 2 types. The way it switches is literally by connecting your power supply one way round or the other. So effectively there's no positive and no ground on here. You can switch it over. So you can see for testing P-type or P-channel, your positive lead goes here and your negative lead goes here. And if you want to test N-channel, the negative goes here and the positive goes here. So just connect it whichever way around you wish. And that simplifies things. Yes, you could use a switch. Bear in mind that these switches, there's no current flowing through this circuit, or almost no current. It's the gate drive. Okay. If you were to switch this, then it could be 10 amps. So you need a good hefty switch. Which brings me to the other feature. So you'll see here from the power in, we do have a switch. This is a 10 amp switch. Go to some higher powered resistors. These are 7.5 ohm, 100 watt each, 3 in parallel, giving 2.5 ohms, 300 watt dissipation. And that connects to drain, which is the same as these resistors. These are the 1 amp circuit, so these are 10 watt, 4.7 ohm in series. Now you'll notice when we switch this in, effectively these 3 in parallel are also in parallel with these for series. But that's absolutely fine because this in parallel is 2.5 ohms. And if you put another 23.5 ohms, which is the sum of these, against that, effectively what will happen is you have a slightly lower resistance. 9 amps will flow this way and 1 amp will flow that way. So it effectively just takes a little bit of the strain off these resistors. As I mentioned, the 10 amp test facility is optional. So if you don't want this, you can omit the switch, you can omit these 3 resistors. If you do fit these resistors, then you need this type, 100 watt power resistors. And I'm using 3 of the 7.5 ohm. Now let's look at the PCB layout. So we can see here, these are the power resistors for the 1 amp test circuit. These are the 10 amp. Here's our switch in the middle. Connectors for your power supply, for the external gate drive, for the MOSFETs you want to test, N-type or P-type, for your voltmeter. You'll see some of the tracks are heavy, so this is where the current is flowing, the high current. I've also made these on both sides with vias in them, so effectively sharing the current between both sides of the PCB. I'll show you that on the 3D view in a minute. Okay. So all the heavy current paths are with tracks on both sides. And I've also made these with exposed copper. So you can literally run a piece of wire all the way along the track or just flood it with solder to increase the current capability. And at the end here, these are the various SMD adapters. And you'll see that I've made these lines are actually cuts in the PCB. So these you can actually snap off. Okay. You can solder whichever device you want to test onto here. Again, some of these are double-sided with these vias in them. to another track on the other side of the board to handle current better. Some of them not so, because some of these packages generally don't come in very high powered devices. Example SOT23, I think 5 amp is the most you're likely to find. So that means, because I've effectively incorporated these in the PCB, you can either leave these on and fit connectors and just run wires across, or you can snap them off and hopefully plug them into here and here with your device on. I think that's a really smart way to do this, to be quite honest. So that's how you test the SMD devices. And here is a 3D view of the PCB. So you can see here exposed areas. This pad under these power resistors is literally just a pad. It's not connected to anything. The resistors bolt down here. Now I'm thinking we may want to put a heatsink the other side of here, but one of the things I want to test when we get this prototype version is use a thermal camera. We don't need to pass 10 amps for very long to take a measurement, so I want to see how well this stands up to that. And then we can make some decisions if we need to, having more resistors in parallel or adding some sort of heat sinking. Again, you can see the little adapters here, they look quite nice actually. And if we flip the PCB over, again you see the exposed copper traces and pads, so you can use solder fill or use wires to run along them. Again, this is for the 10 amp path. You'll also notice I've put the value of the components on both sides of the PCB, so you can actually mount the resistors, set of diodes on either side. The reason you may want to do that is you may wish to have the shaft of the switch coming through the PCB and then connect the various wipers and terminals on the other side. You may want to put the heavy components on the other side of the board. You may want to strap a heatsink onto this side. So there's various ways. You may want to have just the switch and the LEDs and the other switch on this side, and the terminal posts, the 4mm connectors, and then all the other components on the other side. This is really intended to help you build this in the way that fits into whatever sort of enclosure you want to use, whether this is bolted directly to the front panel of some sort of enclosure or whether just the controls on the front panel. So it's for flexibility. We'll see how well that works when the PCBs arrive. I have a to-do list, or maybe do list. So one of the things I was thinking about is adding a 100 milliamp test current range. Some small MOSFETs will not take 1 amp, but then I'm thinking, well, if this is a fake detector, is it likely that those low powered MOSFETs are going to be faked? Yeah, that was one thing I had in mind. But if you wanted to do that, you would just have another resistor around 220 ohms, 5 watt, and that would be fine. That would give you the other range, and you'd have to have a switch to switch it, okay? Another thing I thought about was the accuracy of the Zener diodes. It occurred to me I could replace the 3 Zeners on each side with a TL431, which is effectively a programmable Zener, and you set the voltage using 2 resistors to a reference terminal, and the value of the resistors will set the output. Now, we could use a trimmer pot in here and actually very accurately set the voltage, because Zener diodes themselves are not exactly accurate and the voltage will vary with current, although to be quite honest, the current in this case isn't changing really. I guess it is by the fact you're actually increasing the voltage, but hey, it's a thought. Yeah, we could use TL431, a pair of them, and switch resistors or trimmer pots so we can adjust this and set it up. So that was another kind of to do. Another to do, because there's always more than 2, yeah. Another to do, I need to get the thermal camera out when I've built this, look at the current path for the 10 amps, see if any of the tracks need upgrading, see how well those resistors cope with that and for how long. And I can only do that once I've built the thing. I may also want to add some more SMD adapters. I think I've got most of the common SMD MOSFET types, but hey, I'm sure I've missed some, so I may want to add some more. Now, one of the things we discussed on the previous video, which of course I have a link from this, it explains how to use the fake detector, was the possibility to make this into a microcontroller based MCU project. And Det, as you know, is my resident expert on MCUs, and myself had a good chat about this. And we came up with a few reasons why that wasn't either practical or wasn't really the best way to do this. But to explain that, I need Det, and I think, Detlef, are you around?
What?
I hear Det's voice. Det, get your ass over here, man. Hey,
Guys.
Detlef, why did you talk me out of making an MCU version of this project?
Well, you know, there are multiple reasons. For once, this doesn't need one.
Okay.
Let's see.
It doesn't need a brain.
No, it doesn't need a brain. I think you could do this with a brain, but wouldn't that be overkill?
Well, why is this? Because of development time, or?
Yeah, for once, development time, of course. Well, but the switch does all the work here. So you need good measurements anyways.
Yeah.
And with the complexity you're planning on here, this is at a point where I'd say if you want to have a microcontroller in there, this is probably weeks, maybe to work.
Yeah. Also, obviously, this as it stands, I mean, you saw my version wired together without a circuit board. You could build this on perf board or something
Absolutely.
like that quite easily, or some nails hammered into a piece of wood like we did when I was a kid, you know.
Sure.
So you could do that. Obviously, what you couldn't easily do is the SMD adapters. So if you want all those little adapters, and you probably will do, then
They were a really nice move, yeah, man.
Yeah,
This
cheers.
was a really clever idea to include this in here.
yeah, the idea was that you only buy one PCB,
Yeah.
and then they're all there for you. Yeah.
Well, you get these little adapters. I normally use them when I have my MOSFETs from China.
Yeah.
But for me, this is a great idea. You don't need to order them anyways.
Yeah, exactly. So I think I would agree with that. Also, the other things we wanted to measure or try to measure, like gate capacitance or the turn on and turn off time of the MOSFET, because you don't turn on and off instantly. I looked into this, and really you need to do this with a scope and a square wave generator. And an MCU, because the turn on and turn off time, we're talking nanoseconds.
We're talking nanos here. Yeah.
It's not ideal for that purpose.
Yeah, we were talking about this, and we were thinking, okay, what CPU can do this? And because, yeah, of course there are milliseconds in there and there are microseconds in there, but you are one magnitude lower than the microseconds. This is nano territory. Yeah. And doing this with a micro, I have no idea how to do this. Never did this before.
I did come up with an idea, which was to use the micro to trigger a timer, an oscillator running at a very high frequency, driving a counter. And that when the MOSFET switches off, we just use logic to stop the counter, and then the microcontroller can query the counter to say, right, how many counts did you get? I guess that might work, but again, it's more complex, and you're going to end up with a project that you can't just build on perf board if you want to. So I have to agree with Det on this one.
And me, the microcontroller guy, is saying we don't need a micro here, so this is rare. But there are so many functions in here that you can't easily build into a micro. Well, we see what the people say.
Yeah,
you know,
and on that topic, I'm going to upload this now onto PCBWay as a project. You'll see me do that in a moment. But I actually decided, and I was chatting with Det about this, I'm going to put on my Google Drive and give you guys the link, all the project files, the PCB layout, the schematics, the 2 pages of the schematics, in a form which you can upload yourself into KiCad or any of the other popular...
whatever you use.
Yeah. And you can then work on this yourselves, guys. So if you have any great ideas, any features you want to add, anything you'd like to change, well, you don't have to ask me now. You've got it, yeah. And hopefully you guys will come back, and I'm really hoping, with some modified versions of this, which we can perhaps put something together. It's a community, and then get a really deluxe version out there. But I would still stick with buildability. Okay, so thanks to Det for a few words there.
Yep.
And I will just get on now and show you how to upload this project on PCBWay.com.
So, you do that.
Yep, let's get to PCBWay right now. I'm just logged in at the moment. You can actually see, because it's interesting, I've earned $118 in commissions for shared PCBs. So if you upload your projects and set them to shared, it is optional of course, but if you set them to shared, anybody who orders those projects, either the naked PCBs or pre-built, you get a 10% commission. And look, you can see there. So that's the commissions I've earned so far. I've uploaded maybe 4 or 5 projects, but they've been popular. So guys, that does show you can earn some passive income from doing this as well. You see, I've also earned some beans. Yeah, beans, these are like bonus points they give you, I guess, and you can use your beans to buy things. Look, shows you how many beans you need for each one, multimeter or whatever. So that's something else you get as a bonus as well. I need a few more beans to get something I like, but hey, they don't expire and they just keep building up. Now let's add this project. And this one at the moment, I'm not going to upload as a shared project because I want to test it. This is the revision 0, but the completed version will be shared. I just want to order the PCBs. So quote now, quick order PCB. And we add the Gerber file. This is the Gerber. Here is my PCB. I want this in 1mm thickness. It makes it easier to snap off those various SMD adapters. Okay. Red solder mask. White silk screen. And now I can save my project to the cart, my PCBs. Okay. We wait now until we get a quotation for the final build from PCBWay, and if all is good, then they will build them and send them to me. So that explains how to turn this into a usable product. I'd just like to thank Detlef again for his input on the project, and also thanks to PCBWay.com for sponsoring these videos, which allows me to spend the time to work on these sort of projects. The revision 0 PCBs should be here in a week or so. I have something else to look at from PCBWay this month, so sometime next month we'll get that built and let's see how well it works. Thanks for watching, guys. See you all soon on Learning Electronics Repair. Ciao for now.